as far as speed is concerned, the Spark is much more faster than the MapReduce model, and it actually utilized less number of resources than than MapReduce, Hadoop MapReduce model. And the practicals which has been performed in different labs shows that it can be around 100 times faster than Hadoop MapReduce model. So the number of, if we keep around the same number of nodes in Hadoop model, and we keep same number of resources in Spark model, and we runs the and actually difference you can be analyzed when the data is large in petabyte size. Then if you run the model in both the systems, Spark will turn out to be around 100 times faster. And as I've told you that in memory, it is in processing, it is around 10 times faster. In order to, if you want to fetch the data from it. So now the comparison is not. The next line says that a comparison is not being is not fair, as raw speed tends to be more important to Spark's typical use cases, and it is to batch processing when MapReduce model is solution like Excel. So what happens, guys? Then if you are performing, Hadoop is still better for some of the jobs, but if you are doing iterative computing, if you are doing batch processing, if you are doing the streaming of the data, if you're performing data analysis on streaming, then Spark turn out to be much faster than as compared to Hadoop MapReduce model. So these are the basic features of Spark, and again it offers you the multiple purpose. It gives you multiple purpose sort of utility, where you can utilize the machine learning library, you can use your analytical skills, you do graph processing, and you can perform SQL like queries from the data also, and gives you faster processing as compared to Hadoop. So what are the capabilities of Spark? We'll see those capabilities. The first is stream processing. As I've told you that if you have some running data could be, if you're doing this Twitter analysis, if you're doing the log analysis, the computer logs, or maybe some of the application logs, if you're trying to monitor some of the scales which are coming in regularly, and you performing those log processing, then it is very much faster than any other technologies. So application developers are increasingly having to manage and accommodate streaming sort of data. Such streams related to financial transactions, for example, can be processed in real time to identify and refuse potentially fraudulent transactions. So guys, what happens, like at times what happens, then you are analyzing the data regularly. For example, if you see the credit card transactions, so if you have 50 million customers who are doing the credit card transactions every day, and and if you for example, if I give you one example over here, if I'm in Delhi right now and doing some shopping, and then I did the shopping of around 10,000 rupees, and then I'm again swiping my credit card there, and I'm going to some other mall and doing the shopping of around 10,000, and performing a lot of different transactions in Delhi, and suddenly this shows that a log, every time I do swiping of my credit card, a log has been generated in bank's account that this particular customer with this credit card details, and these are the particular of the customer, and he's doing shopping in this area of Delhi, and which is, and generally in a month I do shopping of around 20,000 rupees, but I did a shopping of around 1 lakh rupees this time. Alarm is supposed to be generated by this person is actually withdrawing or doing transactions so much. So a bank, rather than approving all the transaction, bank should give you a call. Bank should give me a call and ask whether are you the right person who's doing the shopping on your credit card, or is your card stolen or somewhere, which is the the shopping trend shows that it is something which is not regularly happened in the past. So if you're doing such type of log processing out of 50 lakh customers, or maybe 20 2 crores or 100 million customer, you can do these kind of alarms which can be generate and which can do the real time analysis of the processing. And at this point in time, it is very much important for us to have the speed. Another examples of the fraudulent transaction could be that my card is being swiped, or I'm doing the credit card transactions in different areas of Delhi, and suddenly within an hour my card swiping logs says that some shopping has been performed in the retail shop in Mumbai, and immediately alarm has to be created, alarm has to be raised, and bank needs to contact me whether your card has been stolen or somebody is doing some fraudulent transaction on your credit card, because it's highly impossible that a guy who is doing shopping in Delhi and even after 1 hour he can go to Mumbai and do some shopping on it. So these are the some of the log processing examples which can be analyzed and which needs to be analyzed every time, and we need a real time and fastest processing for them. Machine learning, Spark offer a very much scalable and very much easy to use solution for machine learning technologies. As data volume grow, machine learning approaches becomes more feasible and increasingly accurate. So if you have less number of data, if you have less number of transaction, it is not easy for you to analyze, to come up to a right decisions. Whereas the data, the moment the data is growing, and then you apply some machine learning techniques and try to find out what are the inferences of data, what data can prescribe you, then it is more feasible, and for us to apply machine learning techniques and take inferences out of it, and then see the accuracy of the results. More the data, more accurate you will be. And Spark is very much capable of applying all those machine learning, clustering, regression, classification, k-means clustering. A lot of machine learning algorithms are built in those models, wherein you can actually do those apply those machine learning models in Spark. Software can be trained to identify and act upon triggers. Like I have given you the example of fraudulent transactions. There should be a trigger which needs to be generated, and inform bank that there might be a possibility of some fraudulent transactions within well understood data sets before applying the same solution to new and unknown data. So if we are able to identify that yes, these solutions which we were using and the models which we have applied are correct on the present data set and the training and test data set, then we need to apply those model in the upcoming data sets, and then we need to find out whether then it is applicable on new data set or the unknown data set, or whether my models are model needs to be upgraded or changed because the data is changing and it keeps on changing every time. Spark ability to store the data in memory and rapidly run repeated queries makes it a good choice for training machine learning algorithms. Like I've given you the example, if you need to perform the iterative machine learning algorithm, if you want to apply iterative machine learning algorithm, that you have certain data set, you want to take the inferences out of it, and you apply certain machine learning algorithms, and you need to query the data every time. So in Hadoop model, what happens, like you cannot you have to fetch the data from storage, and then you apply machine learning techniques, and then the data gets stored in the storage again, and then you fetch the data for next processing. For example, in this section, it is very much easy for us to query the data because it's of the in-memory task, and then you query the data again and again and repeatedly in order to fetch the inferences. Interactive analytics. Business analysts and data scientists want to explore their data by asking a question, viewing the results, and then either altering the initial question slightly or drilling deeper into the results. For example, if I want to see where are my potential customers in complete India, so what happens, like you might see that there might be a salary segment, there might be the population which could be the factor, and you apply those statistical model, and then you try to fetch the results, and then you saw the results, and see what exactly the analysis says. And then suddenly you realize that there is one more factor, which could be the job, which could be a new the new company which is being setting up. A lot of things can happen to an area, and which might change your results, if you want to see that where could be your potential customers. So you want to alter those statistical model, and we try to view the results again in order to come up, if you want to do some hypothesis testing, or if you want to identify whether your predictions are correct or not. And then for those interactive analytics, if you want to get the immediate results, and then you apply the query again and you want to see the results again and again, it is very much easy for us because the speed is much more faster. Spark allows them to do this whether they are looking at the stock prices or production line productivity. That's again, if there is a production line, or if there are stocks which keeps on changing every minute, every 30 seconds there are changes in the stock price, and then you want to predict which what exactly the behavior of the stock is, and what or the behavior of the people, what is the behavior of the people, then you can always go for Spark, and it gives you interactive analytics sort of environment where you can do iterative results, and you can perform those analysis again and again. Data integration. Data produced by different systems across a business is rarely clean or consistent enough to be simply and easily combined for reporting and analysis. Spark and Hadoop are increasingly being used to reduce the cost and time required to clean and standardize data, then load it into a separate system for analysis. That's a self-explanatory option that we have. We have a lot of data integration model wherein you can actually reduce the time for cleaning and summarizing or standardizing the data, and data can come in different formats, and then you perform those cleaning techniques on it, and then you put that into a standard format. Okay, so this is again a proper graph of how much time Hadoop took to perform a certain job, and you can see that Hadoop graph is on the much more higher side than the Spark side. The first time, if you can see that around 921 million 921 million 150 million rows, this when has been performed, and it took around 921 seconds. And then if you perform iterative algorithm in Spark, and when you put the data in HDFS, it took larger time, and then you do first iteration and second iteration, it takes the same time. Wherein if you're doing Spark, and if you are doing it in memory processing, Hadoop takes this much time, and then in first iteration it took lesser time, and in the second iteration keep on taking less time as compared to the previous iterations. Around again, if you perform certain quasi-Newton method in enhanced memory methods, then again the second iteration is performed seamlessly. That means the results are pretty quick as compared to the Hadoop if Hadoop is performing MapReduce job.